Yeah, want to show that the Laplace of this, okay, of exponential to power 80, okay, is equal to this. Actually, from the table, we know that Laplace of this is equal to this. But we want to show that, okay, let's do that, okay. If we want to show that, we need to note that the definition for Laplace is equal to integral from 0 to infinity of this f of t dt is equal to, this is equal to limit as n tend to infinity from 0 to n f of t dt. So what we have to do is that we know that f of t now, in this case now, f of t, in the given problem, f of t is e to power 80. We just plug in there, okay? And then we get the Laplace, okay? And don't forget that f of x, the symbol is f of t. That's the symbol. What I mean is this: the symbol f of x is equal to Laplace f of, this is just L, f of t, time domain, and then put the x there. Okay. So without wasting time, this will be equal to limit as n tends to infinity of integral 0 to n this s times f of t we are given dt. Okay. So what we have to do now is for us to just work this integral first. We'll solve that integral first. Okay. So this will be equal to, take the integral out. Let's take that out. Combine these two together. Then we have exponential. And that will be a minus x bracket t dt. If you combine these two together and start with the positive a minus x, I'm applying indices equal the same basis. Then you take one of the bases and add the power together. If you integrate this will be equal to e a x t all over what? All over a minus x. Put your upper and lower boundary there. The upper, the lower boundary. Then you can substitute that. If you substitute that, you have e to a minus x n all over a minus x. That's for the upper boundary. Then minus the lower boundary. That's 0. If you put 0 here for t, that will be e to power 0. That's 1. That's 1 over a minus x. So that's what we have for the integral parts. Okay, so let's now put the limit there now. So Laplace of e at, okay, will be equal to limit as n tends to infinity of these brackets, which is equal to a minus x 1 over. Okay, and this will give you just minus 1 over x a minus x Okay, and this minus could be up, could be down. If it's down, that will be equal to what? 1 minus what? 1 minus x minus a, where x is greater than what? It's greater than a. Okay, and that one is shown, and that one is done. But you must note that the limit, limit of as n tends to infinity of this function, that's equal to 0. But when you have a limit of difference of function, it will be limit of this and limit of this, and this is just a constant there. So that's why we just have this, and this one will tend to 0 as n become larger.